is the relationships between chemicals in a balanced chemical equation. So your relationship or your stoichiometric relationship could be reactant to reactant, it could be reactant to product, it could be product to product. And we use mole ratios to set them up. For example, aluminum can react with bromine in a synthesis reaction to form aluminum bromide. Two AL. Beautiful. Okay, so stoichiometrically, 2 atoms of aluminum react with 3 molecules of bromine to produce 2 formula units of aluminum bromide. Stoichiometry uses the coefficients from a balanced chemical reaction. So if we have a quantity of, let's say, aluminum bromide that's produced, we can figure out how much aluminum we need, or how much bromine we need. Or if we know how much aluminum we have, we'll know the maximum amount of aluminum bromide we can form. So this is really important in chemistry. So we're going to set up some mole ratios. We've been doing ratios already, and we've been doing them as fractions. So write out a ratio for any 2 entities in this reaction. Ratio. Substances in this equation. Would I have sodium in my ratio? No, because there's no sodium there. There is aluminum. Give me another substance. Rebecca, bromine or aluminum bromide? Pick one. Okay, aluminum bromide. Thank you. This is a mole ratio. 2 moles of aluminum will form 2 moles of aluminum bromide. And I get those numbers from here. You can also flip that and have 2 aluminum bromides for every 2 aluminum used. So 2 aluminum bromides will be produced for 2 aluminums used. Can you give me another mole ratio from this? No. Or are you just shaking the webs out of your... Too tired. Danny? So the thing about mole ratios is we can flip them and the relationship stays the same. We're going to use them to convert moles or mass of something into something else. So, I don't want to times. You could, the same relationship could be 2 aluminum bromides over 3 Br2. It's the same relationship. So, if I make 5 moles of aluminum bromide, how much aluminum do I need? How many moles of aluminum will I need? You can use mole ratios to figure that out. Ooh. So to show your work, 5.0 moles of aluminum bromide. Make sure you put in your AlBr3. And we are going to multiply this by a mole ratio to get aluminum instead of aluminum bromide. So, this is very much like dimensional analysis, but you have to do it this way for mole ratios. So I have aluminum bromide on the bottom so that it cancels. Aluminum on top, because that's the unit I want. And then you put in your coefficients from your balanced chemical equation. So I would need 5 moles of aluminum. Your AlBr3 would cancel. 2 over 2 is 1, yeah. Now, find out how much bromine I would need. Br2. So this time it's times 3 moles of bromine over 2 AlBr3. Five times 3 divided by 2. You would need 7.5 moles of bromine. And if you look at the mole ratio, 3 is bigger than 2, so you do need more bromine. All right. Called? Yeah, the law of conservation of mass says you have to balance the chemical equation because the mass of your reactants is equal to the mass of your products. So try this question.
I multiplied it by 2 NH3 divided by 3 H2. I got 4 over 3 moles.
And what is 4 over 3 is a decimal?
1.5.
What is 4 minus 3?
0.
Oh my gosh. Now you're just being difficult.
No, it's 1.5.
1 1/3. You have
I was
1
close.
left over.
I'm not doing too far enough, right? You don't need to call me exploding.
So you can make 1.3 moles of ammonia. You okay with this?